Welcome to the fourth and final part of the third tutorial in the SIDD online tutorial series. So we've already gone through defining the subject for analysis in the first part, altering the model code in the second, generating policy counterfactuals in the third part, and now we're getting on to analyzing model output. Now, there are really, to my mind, three key tasks whenever you're trying to analyze model output. The first is to try and interpret the incentive effects for population aggregates. So this is really just trying to get a grip on the responses that the model is generating for a particular policy counterfactual and understanding why those responses are being generated in context of the respective incentive effects embodied within the counterfactual. The second is to analyze the distributional variation reported by the model. Basically, a key justification or motivation for using this type of model is that it allows distributional analysis to be undertaken. More specifically, the idea is that it accommodates the possibility that responses to a particular policy counterfactual vary non-linearly across the population. If the population responses to a particular policy counterfactual could be described by some sort of linear function of income, then actually you could analyze the particular policy counterfactual of concern more efficiently using representative agent modeling approaches. Finally, the third step of the analysis involves packaging the results, and this is often non-trivial. The idea really is to come up with some tables or graphs that are likely to describe the principal responses that you have identified in the first two parts of the analysis in a very accessible format. Now, each of these tasks really involves different tools. Typically, my first tool that I look at whenever I consider a particular policy counterfactual is to look at the decile level statistics that come pre-packaged within the model structure. You'll recall from the third part of this tutorial series that we set up the counterfactual simulation so that it would generate decile level statistics and generate within the decile level statistics comparisons with the base simulation. It is this analysis output that comes pre-packaged with the model, which I tend to look at first whenever I'm trying to work out what's going on with a particular policy counterfactual. Whenever you come to packaging the results, either you'll find that you can obtain simple summary statistics from the detailed level statistics that are generated by the model by default, or you'll need to produce sort of bespoke routines in order to package the output in the way that you have envisaged. Now, for this purpose, either we have tended to use Stata. You basically import the microdata into Stata and then use Stata routines to analyze the microdata, or Fortran, and the materials to this tutorial include a series of Fortran routines that were designed to generate the tables that are reported in the paper that is also available for download from the tutorial website as part of the materials. So that's it really as an overview. Let's get into actually looking at the model structure. So I'll jump to a workstation where I have all of this analysis run. You'll recall from the previous part of the tutorial that we've been using this temp directory. All of our simulated results have been generated within this SIDD subdirectory. If I go to the simulation subdirectory, here's the first simulation we ran in order to set up the model base. A second simulation which also was involved with setting up the model base. And here is the counterfactual, which generates a 10 percentage point increase in all income tax rates and simulates the effects of that policy counterfactual, allowing for endogenous behavior responses both in terms of savings and labor supply. So if I click on this file here, one of the files that was produced by default is analysis_dec. This is the decile level analysis that I referred to earlier. If I open that up, you'll see it's populated by zeros. This is the default. Basically, it indicates that nothing's being loaded in. Basically, this version of the model has been run suppressing communications directly to Excel in order to load the results in from this particular simulation. We press Alt F8 and select this update data macro and run the macro. Now this macro runs through and is now complete, and basically the spreadsheet has been populated with the simulated data. There are two sheets here: sample averages, reporting the sample averages by age and lifetime income decile across the top here. For example, number of adults, consumption pounds per week, leisure, and so on. And then differences with base, which is just the sample averages reported again, but subtracting the base statistics for those deciles from the decile level statistics that are reported here for the respective counterfactual. Note importantly that the deciles, the description of the deciles are with respect to lifetime income earned under the counterfactual simulation. So basically it's comparing, we've ensured that it's comparing like with like. The same households are identified within each of these population subgroups, both through time and between the base and the counterfactual simulation. So everything is I suppose you might say, as it should be. Now, these are decile level statistics. If you go all the way across to column GB and so on, you'll see population averages. And you'll recall from the PowerPoint presentation that I just went through that this is the place to start. It gives you a high-level overview of what's going on. Basically, as you might recall from the last part of the tutorial, we basically have projected these decile level statistics for a birth cohort, a series of birth cohorts. The birth cohorts in this case were born between 1981 and 1990. Given that the population, policy counterfactual is assumed to apply here from 2016. The youngest cohort will have been born in 1990 and will be age 26 when they're first affected by this counterfactual. And you can see if we click on this cell here and go across, this is the first cell, age 26, where the number is non-zero. These are non-zero because they're defining lifetime income distribution, and so your lifetime income is the same throughout your life. So let's start with, you'll note first of all that number of adults shows no differences here, and that's primarily because demographics number of adults, marital status, timing, and number of births, and so on. Deaths are all simulated exogenously of the utility maximization problem, so they're the same regardless of the policy counterfactual considered for analysis. So we can skip right over the number of adults and go to consumption in pounds per week, and if we just plot that, we can see how these consumption figures per week vary through time. If we go insert and we'll just do a basic line plot, you can see that, you know, the effects are non-trivial. You're talking about up to 20 odd pounds a week. If we add in the ages for these points, we can do that just by altering this equation here. Now we've got ages across the horizontal, and we have pounds per week on the vertical. So basically this, at its peak, the counterfactual is implying a reduction in weekly consumption of around about 20 pounds per week, at ages between 42 and 52. Note that there's a sharp incline here, or decline. This is partly because of the fact that we have a number of different cohorts, 10 birth cohorts, you know, between born between years 1981 and 1990. And so increasing numbers of those birth cohorts are being affected as you move through the age group. So in other words, those who were born in 1981 only start to be affected by this policy counterfactual at age, what is it, 35. So basically that's around about here. So basically this is the first year at which all of the birth cohorts are being affected all at once. Otherwise you've just got increasing numbers of birth cohorts being affected. And that's describing this smooth transition here. Then it moves down and it sort of comes back up. It does this. So this is actually somewhat difficult to provide any strict interpretation around. Obviously they're going to be consuming less because their disposable income for any given measure of labour income will have been altered. So that's sort of difficult. If in contrast we look at leisure, this is much more interesting. Now in this model it can be sometimes difficult to work out what's going on when you're looking at numbers employed, and the reason for that is that well, in this particular calibration I'm not really very happy with the projected numbers of employment. I find that the leisure metrics tend to provide a much better indication of the bearing of policy reforms on labour supply. Now, recall that leisure is really sort of the counterparty to labour, and so when leisure goes up, labour goes down, and vice versa. It can be useful sometimes to try and convert these leisure figures into something much more tangible, and to do that I would normally take some sort of measure of measures of full-time adult employment. So to do that you can, for example, multiply so this is hours, so this is time in leisure, leisure time. You would need to back out the numbers of hours of work. So basically here, oh gosh, if I grab that and delete it, if we say that there are, for example, 15 hours of useful time per year, per day, and let's say, and there's 7 days per week, and then we multiply it by negative the leisure time, because this is leisure is reported here as a normalized figure. It's normalized to 1 as a total. So that would be the total impact on average hours per adult per week. And if we then sort of multiply that by 60, it gives us the number of minutes per week, for example. So and if we then go down and we sort of copy that down, you can see that we're getting to sort of 20 odd, well, half an hour or thereabouts at its peak as an impact on time. So if I just do this, now recall, well, this is by age, so that seems fine. So these are minutes of effect, of minutes per week. In the average number of minutes per week in employment per adult by age, recalling that we have to copy it and paste this over to get age on the horizontal axis, which is what is a bit of a pain. So so that gives us minutes per week. You can see that the peak here is around about 40 minutes per week at age 39. So labour supply is declining by approximately 40 minutes per week per adult at age 39, and then it inclines again, and then so it's plus 15 minutes per week at age 54, and then it sort of bumbles around at 0. So basically, this is a sort of a really neat effect. It's indicating that the policy reform is increasing the average tax rate. That's reducing the disposable income that an individual gets for any measure of private income. In other words, it's effectively reducing the effective price of leisure. That is, it's reducing the disposable income that an individual has to sacrifice in order to purchase an additional unit of time of leisure. So the optimizing adults in this model choose to sacrifice consumption for leisure, and that's sort of interesting, because basically there are two key effects in this reform. There's this price effect, which I've just referred to, which is encouraging reduced labour supply, especially during prime working years. And then there's a wealth effect, and the wealth effect is actually working in the opposite direction, because you're making people lifetime poorer, and these individuals who are lifetime poorer therefore need to work harder in order to achieve the same measures of pecuniary wealth. And so these two things are working in opposite directions. Early in the lifetime, it's the price effect on leisure that is really dominating the bearing that the model has on leisure. And then later on in life, it sort of leads to a bit of a switch, although there's still some evidence of early retirement. This switch can be understood as basically an attempt to make up some of the lost income, both due to reduced labour supply and the increase in the effective tax rate that the people are subject to. So that's labour supply. If we now if we grab that, we go up to the top. Okay, and we take this and we now have a look at private income. We can then see the bearing that labour supply has on private income. Now, labour supply sort of leading to this decline in private income here. But note that it's not just not just employment income that's falling, but it's also investment income. And the investment income decline can be seen, the reason for the decline in investment income can be seen if we simply take this and we go over to measures of, for example, total wealth. Here's the impact that the projected impact that the policy has on the average individual within the 10 birth cohorts that are selected here with age. And you can see that, you know, wealth declines really very substantively by almost £45,000 by age 80. So the combined impact of reduced labour supply and increased taxes leading to a reduction in wealth, and that leads to a reduction in investment income and an attempt to make up some of the decline in investment income or decline in financial circumstances, you know, at sort of these early retirement years. And overall, the bearing on consumption is fairly non-trivial, around about 20 odd pounds, then rising sort of again, but not really very much, to 15 pounds per week later in life. So these are the key sort of effects that are then the incentive effects that are then driving results within the analysis. If, as I noted in the preceding, the PowerPoint presentation, it's interesting often to, given these effects, look then at some of the distributional variation. Clearly, labour supply is really a neat thing to look at here. So we'll just zip over and have a look at the decile level statistics for leisure. And usually what I do here is I will select a bunch of ages, and then I'll select a number of deciles to look at all at the same time. So here I'm selecting 5, and here you can see it's a little bit noisy, but if we then grab a couple just to provide an indication of how things are altering across the distribution. So okay, so that's the top decile, the 8th decile. Maybe this is too many actually. Why don't we just take 3 instead? And I'll grab that, and I'll take just the 3, and this should hopefully give me something much clearer. Oh, that's annoying. Okay, so I'll try it again. Insert, graph, grab the graph, grab that, zip that across to 10. That's the second one, so we'll bring this over to 5. Okay, so here we can see what's going on from a distributional perspective, and it's really quite interesting. Okay, so this is the highest decile. Now, the highest decile tends to, at least if we look across here, display lower leisure, in other words, higher labour supply almost throughout the simulated lifetime. Now, that's primarily because the highest decile is the decile that is subject to the strongest wealth effects. You'll recall that in my discussion just a moment ago that the wealth effect is actually encouraging people to supply increased labor because the higher tax rates are effectively making them work harder for each pound of disposable income. So the response to the highest wealth decile is to actually work a bit harder as a result of this policy reform. In contrast, you can see that it's the middle decile where the price effect is really dominating very clearly. You can see that that in this red peak here. So it's the results in the population. So this is sort of really clearly, reflecting the kind of results that we're seeing in the population average. In contrast, the lowest decile here isn't much affected at all, really, relative to the other two, and that's because taxes are far less important for this population subgroup than for the others. So the population average effects that we just discussed in terms of labor supply are really being driven by families below the very top of the distribution and above the very bottom of the distribution, sort of, the middle of the middle population subgroups. So that sort of gives us then a really nice feel, I suppose. At least it gives me a really nice feel for what is driving these results and what is going on in terms of or underlying the effects of the policy counterfactual that are projected by the model. So so that's the decile level statistics. Now, in packaging these things, you'll see you can see effectively how I've chosen to package these results in the particular paper that is reported for analysis, and then indeed how I've gone about discussing the results in the body of the paper. So hopefully that'll give you a nice feel for how at least I go about this sort of analysis. The only other point that I would make is that you should find in the materials of this this tutorial this analysis progs subdirectory. If you open up the analysis solution, this, as I mentioned a moment ago, this solution includes all of the routines that I used in order to package the results. So basically the bespoke simulation routine, analysis routines that I generated as part of this analysis. Now, you may find this a little bit overwhelming to begin with, but the best place to make a start is this main routine. If you double click on that, you'll see that basically this is where the routine enters, and basically if you follow it through, a lot of stuff is commented out because it includes this routine, this package includes a lot of different analysis routines, and I commented them in and out as I wanted to use them. Hopefully they'll be reasonably straightforward to interpret. If not, obviously you're more than welcome to send requests for clarification by email or in the comments to this tutorial sheet. I wish you the very best of luck in your own analysis, and have a nice day. Bye-bye.